Welcome, everyone, and sorry for letting you wait. We were just giving people a little bit of time to join. My name is Anna, and I work on the Elastic community team. And I have the pleasure to introduce to you Ioannis Mavrokakis, who will talk to you all about load testing Elasticsearch with Gatling for fun and profit. So I'll hand over to Ioannis now. Just a few housekeeping items. Please ask questions in the Q&A chat thingy, which you see at the bottom. Please don't drop them in the chat. It's easier for us to keep track of them in the Q&A. So Ioannis can take questions after his presentation. There should be plenty of time for him to answer your questions. I am also recording this meetup. So if you would like to watch some parts again, or there's something you missed, you can see a recording on our YouTube channel, which will be up tomorrow. But now I'm handing over to Ioannis. So yeah, welcome.
Thank you very much, Anna. Lovely to be doing this. So hello, everyone. Once again, thank you for attending. As Anna has already mentioned, my name is Ioannis Mavrokakis, and I'm a developer for Insight Enterprises. And the fun title of my presentation aside, I'm going to talk to you about how you can efficiently load test Elasticsearch with a focus on the needs of your application and queries. There will be a few slides, I promise. Most of the presentation will be code and a little bit of a demo. So let's get started. At Insight, we use Elasticsearch to drive our product search engine, and performance is very important to us and our customers. We needed a good approach to test that both our index setup, application, and query performance was well within the SLAs that we had actually set ourselves. Now, figuring out how to best set up indices poses a lot of questions with regards to actually quite of the basic stuff. It's like, how many shards do I need? What's the shard count? What's the size? How many replicas? And so on and so forth. And, you know, there's several resources out there. I'm sure that if you search, you'll find quite a lot of stuff. But obviously, the most efficient approach is to actually do your own tests, design and run your own tests. And for me, in order to get the best results, your tests should have, you know, these three following characteristics. They need to be repeatable, they need to be automated, and they need to be in code. You want your tests to be repeatable because if you want to run the same test with the same parameter multiple times, you should get results that are actually very, very close to each other. And that's really important. It tells you that your test is actually, at the very least, is producing the right results at the right time. You want them to be automated because you want them to run quickly and often in order for you to actually spend more of your time on the analysis of those results and not teeing up and setting up the execution run. I mean, think, for example, running a canary performance test right before a release, right? You don't want to spend ages doing that. And finally, you want them to be in code, right? If your tests are expressed in code, that means that you can relatively easily pull in your own application libraries, right? Your domain, the stuff that you are actually interested in, and test the things that actually matter to you. So for all these things, what actually fulfilled the requirements that we set ourselves was combining Jenkins with Gatling. I assume everybody knows Jenkins, or at the very least the crushing majority. For anyone who has not heard of Gatling, Gatling is an open source load testing framework that has been written in Scala and comes with a fairly powerful DSR. It has support for HTTP pasting straight out of the box, among other things as well, but it is also extremely extensible, which means that what you can do is you can write your own testing protocol in Gatling and delegate the execution and automation to a Jenkins job. Now, we are actually going to go straight into a demo, and I'm going to show you what we've got here. Oops, Do that. Hold on while I try to get out of the. There we go, much better. That's it. Excellent. I'm assuming you can all see my screen. So this is something that I had set up earlier, so I can show you a very, very high level overview of how a load test will work. What I'm using for my demo is something called the Behavioral Risk Factor Surveillance System. And that is a data set that you can actually find at the United States CDC Center. And it's also available in one of the Elasticsearch repos. So that made it a very good candidate for this. What we are going to query for are actually responders that have had both a heart attack and a stroke, right? And in order to demo the incremental improvement in your query performance, I have actually set up the same index with 1, 2, 3, and 5 primary shards with 0 replicas. And obviously what we expect to see is a gradual performance improvement as we are going from 1 to 5 primary shards, right? So you can see here that I've got the tests already set up. What I am going to do is I'm also going to fire off a few more now. There we go. Excellent. So you can see that Jenkins has already teed off the next set of steps. What I expect to see is while I'm testing the same indexes with the same parameters, same characteristics, I'm expecting to see that curve being replicated almost as closely as this one, right? New curve, almost same results, which means that my tests are good. So I'm briefly going to demo what I've set up in the UI. There we go. So this is a load test that I've set up to accept a few parameters. I want to be able to control how many users per second I'm going to generate against Elasticsearch or against my libraries, my query, whatever. And I want to be able to control the amount of time that I'm going to run the simulation for. Now I've given myself an extra option. I want to actually record only the Elasticsearch engine response time instead of the overall application response time. This differs. I mean, you might obviously be interested in everything. You might be interested in Elasticsearch. That's just an option that I've built into this so that we take any bizarre network issues out of the equation. All right, that's relatively simple to do, and that's done. Whilst we're here, I'm going to show you what one of the reports from Gatling looks like, right? Okay, so we are just quickly going to download this. And I'm going to open up the results. Now, as you can see, this is my single shard test. Not great. We had 1,530 requests, and everything was over 100 milliseconds and under 500 milliseconds. We can see that I've had no failed requests, which is great. And you can see some basic percentile information, which is obviously really important when you make your decisions as to what to test, and you record your results. Now, this is the global view. Because I only have one test, it basically shows you only one error. You would have actually been able to look at them in detail. So this is my heart attack and stroke test. And we can see all the requests that I've done here, again, with the same setup, with the same numbers, only one test. But interestingly enough, we can see the response time distribution, right? So there's a bit of a curve going up here. We can see that our responses are all over the place. But this is very important when you actually try to optimize your queries. I mean, ideally, you want everything bunched up to the left, but this is a demo, and that's what we're going to do with this. So that's the results you actually get from Gatling. So not only can you download this, but you can get a very, very high level overview from the plugin itself with mean response times, 95th percentiles, and any requests that may have died. Fortunately, we have no requests that have failed here. So how do we do this? How do we put everything together? So it's time for a little bit of code now. Let's see, let's make this a little bit bigger. There we go. Good, great. So this is a pipeline. For those of you who are unfamiliar with Jenkins pipeline, it is just a declarative bunch of steps that allows you to perform some actions on a job. Okay. It's not very interesting what happens in the first two stages. We have our checkout and our build, but here's where things get a little bit more interesting. We actually use a feature in a Scala plugin to pack our application. This is the equivalent of a Spring Boot fat jar, right? It gives you the libraries, the actual code, plus a little bit of glue in the form of a shell script so you can run the whole thing together. And we actually stash this. Stashing it means that I want Jenkins to keep it somewhere handy for the duration of the build because I'm interested in using it later. The actual load test itself happens in these lines. You'll notice that I've departed from the declarative approach and I'm using the scripted approach. This is because I want to control as much as possible in terms of the execution, right? I've got some variables I need to set up. I've got some decisions I need to make. Script is what I need. I use Groovy, which is the language of choice for pipelines, to write these things in. Right off the bat, you'll notice that I've got this little if statement here. If users per second is greater than split tests above. Well, this is an arbitrary decision I've made. And I've said that if my user gives me more users per second than some number, and that happens to be 30 in my instance, then what I want to do is, given the number of test nodes that Jenkins has available to me, I want to actually split those users divided by the number of test nodes. I mean, okay, you're going to get some loss of precision here, but it doesn't matter for this particular purpose. What's the point of doing this? You have to understand that although Gatling is very, very powerful and it uses can play behind the scenes and it can be very resource efficient, it can actually drive a node into the ground if you give it lots and lots of users to actually test it. So what we're doing here is we're being clever and we're saying that, oh, okay, I know that my Jenkins node can only handle X amount of users. I'm actually going to split this across all my nodes and see and get a number that I'm going to distribute across my entire Jenkins fleet and have them all run at the same time. And I'll show you where this is done. So we will iterate across our test nodes, which can be anything from 1 to however many you've set them to. And this is basically our entire test procedure. Okay, the interesting part is actually this is here. Okay, so we have a load test binary that's been unpacked, and we pass it some parameters, which is our Elasticsearch URL, username and password, which I hope everyone is using. In my case, the index name I'm going to be testing against, however many users per second I want, and the test duration. Now, these are not provided with Gatling out of the box, but we said extensibility, right? So you're using Gatling, especially like your library, your testing library, and you're building on top of it. So you can find great things like Scala, which is what I'm using here, that actually creates command line parameters for you very cheaply, very quickly. So you concentrate on testing and not switches. And I'm telling it that, hey, I want you to test my heart attack and stroke search, right? So you can see that it's very expressive. You can see what you're doing. You can see what you're testing. So this is going to go off and it's going to run the test. Everything's going to go fine, hopefully. And at the end, Gatling leaves behind called a simulation log, which is basically a recording of your entire run with times inside it and extra information that Gatling knows how to process. If you've got that, what I want to do is I basically want to stash it for every single one of the nodes that I have. If I have more than one nodes, then obviously this is going to change. It's going to be 1, 2, whatever. And here's the magic. We use the Jenkins parallel plugin to actually launch and run all of this across our nodes. So our parallel is going to take it, and for as many entries we have in this map here, it's actually going to run as many tests, right? And that's great. Once that's finished, it's time obviously to collect our results. So we want the results to appear both in Jenkins, but we want them to be archived for further use, because you want to download them, you want to be able to look at them. So again, according to the number of test nodes that I have, I'm going to go and I'm going to unstash all the simulation logs that I've actually stashed up here. Okay. And now, again, I'm going to switch my load testing application that I've done into reporting only mode. I've just got a switch that says report only. And that basically hooks back into Gatling and tells Gatling, hey, I want you to write in report only mode. And when Gatling sees that, and you pass, write the appropriate directory for it to find the results, it's going to go and automatically pick up all the simulation log results you can find in there. Excuse me, and it's going to basically create those lovely, lovely graphs that you saw, those HTML reports. And as a bonus, once you call Gatling Archive is a Jenkins plugin. It's going to do the same thing. And what you're going to see is basically this. You're going to see entries in the load test and performance trend. And you're also going to get this beautiful mean response time trend, which actually, good timing, we're coming back to this test. Okay, you can see that our tests are repeatable. They're very, very close. They're reasonably close, right? Reasonably close to this, reasonably close to this. And remember, this is the one shot. This is, what was it, 2? Yes, this is 2, this is 3, this is 5. So we know that we're actually getting accurate results out of this. So that's the glue. That's how we automate everything via Jenkins. And you probably may have noticed I may have done it a bit too quickly, but using the Jenkins CLI, you can actually automate this even further. You don't even have to go to the website to do this. You can pass all your parameters here, and Jenkins will tee everything up, and you run. Great. So how does this actually work from the perspective of Gatling and Elasticsearch, right? So this is like the simulation. This is what we're telling Gatling, I want you to do. For a given duration and a set of given users per second, we want to run some scenarios. And this is, if you're not comfortable with Scala, and Lord knows I'm really not comfortable with Scala, this is the Gatling DSL, okay, or rather a part of the Gatling DSL. So what I'm telling it is, hey, load test runner, if you see that I want you to do the heart attack and stroke search, I want you to add to my scenarios list this following scenario. Now, from here on down, we are actually in Gatling territory, okay? I have a scenario, I'm going to give it a name. I'm going to provide it with a search service feeder, which I'll explain what it is in a minute. And I'm telling it that I want you to execute this particular, this is basically a class, okay? But I want you to execute this particular class that comes from this method, heart attack and stroke, and pass the host parameter inside, which is going to be your Elasticsearch index URL and port name. And finally, once you've got all this information, I want you to run the actual injection of users, right? We still need the users that are going to run against this thing. And I'm telling it, and again, this is Gatling specific, it's got loads more. But the simplest thing you can do is, like, I'm telling it to ramp all your users, ramp users up 1 per second until you've reached the amount of users that I want you to test with, and do it over the period of 1 minute. Once you've done that, I want you to switch modes, and I want you to actually run constant inject, constant user per second with the number of users that I've told you to during the duration of the test. So if we go back to our Jenkins build, you can see how these work, right? Here's your users per second, 5 as default, duration 5 minutes, okay? And we've got the Elastic URL here as well. So once all that is done, I call a setup on the scenarios, and I give it my protocol. So now that's my custom work. That is my protocol. I've created this specifically for my search needs. Obviously, if you have more than one, okay, you can set up loads and loads and loads of little scenarios, add them to the list, pass them on, and search. Okay, so that's the Elasticsearch simulation. That's what Gatling is going to look for to run your tests. Now, I mentioned search service feeder. Search service feeder is nothing more than a builder for my Elasticsearch connection and credentials. Okay, that's where I set everything up. I pick them up from my command line, and you'll probably recognize that most of this is Elasticsearch specific, right? I set up HTTP hosts, and I use providers and credentials, and I build my builder. But I do something funky here. I'm saying that this is a circular. What does that mean? So a circular feeder in Gatling parlance is basically a feeder that can provide multiple entries, and once it reaches the end, it cycles back to the beginning, right? It's like it's a circular array. In this case, we only have one, but there's obviously nothing stopping you from adding more than one. Okay, so you may want to test servers individually. You may not want to test Elasticsearch directly. You may want to test your application that connects to Elasticsearch, and you have different load balance servers, and you don't want to use the load balancer. You want to hit each one of them individually. Okay, a feeder is a great way to do this, right? So everything is going to just cycle through, and you get an even spread of connections. Now, Elasticsearch service. Elasticsearch service, you notice that I called, oh no, sorry, I'm getting ahead of myself. I want this. So this is the main method, the main action that I'm going to run. It's called heart attack and stroke query action. Okay, this is again Gatling specific. Gatling expects actions to have this sort of format. You don't, you can just copy paste. I don't mind. I'm okay with it. But everything, your whole code should be in this execute method. Okay, so you see here that I'm passing a session, and that session actually contains the search service that I mentioned earlier. And what happens here is that I have my search service. I call this method that actually gives me the search request, and this search request is Elasticsearch. Okay, let's see if I hit the right combination. There we go, Elasticsearch service. So this is nothing fancy. I've just written like a mock library, like I'm pretending that this is my domain, this is my library, this is what I use to actually query for folks who had heart attack or stroke. I've made a very basic data query framework, but all I'm doing here to search request is I'm converting these into query builder. Right? You can see query builder of a type bull query, and I say, is this an AND query, is this an OR, is an OR? I mean, it doesn't matter in this context, but I'm just showing you that you can either go really low level next to Elasticsearch, use Elasticsearch facilities, or you can move further high up and use your own library. Okay, so I'm kind of pretending I'm doing both. I've got my heart attack or stroke, and then I translate this to an Elasticsearch query. So if we go back, I've got my search request now, and I'm logging my start time. That's when I started, and I'm running my query. Okay, this is going to run straight against the Elasticsearch index that I've set up. And as soon as that's back, I'm done. I'm logging my stop time. Now you notice that I've got two options here for end. I've got clock end and end. Possibly horrible what I will name it, but forgive me for that. I have the ES response time because I had an option in Jenkins where I said I could be interested in my entire application time query response, which would be this, but I also could be interested in how Elasticsearch actually responded. I don't care what happened in between. I don't care about the network. I don't care about anything else. I just want to know whether my query was fast or not. So I can make a choice here. And again, this is all the benefits of doing everything in code. You can do this gymnastics, right? You can set up anything you like. As soon as I've got this, again, a bit more Gatling, I log my response, the name, the start, the end. I'm saying that this is an okay response, and I'm done. All right. For the eagle-eyed among you, you probably noticed that this is done in a construct called future. Think of this as a thread. Scala purists are going to kill me for this, but I come from Java. I think of this as a thread. Once this is run, I'm effectively unblocking the testing framework. And when it completes, and I call it complete, if it has been successful, I'm happy. I move on to the next session. If there was a failure, could be, then I log the response, because we obviously want to know why things failed. Throw something in the logs in case you're watching the logs, and I mark the session and failed, and I am done. So at a very high level, this is like the minimum you can put together to get a very neat, lean, and responsive framework. Now, obviously, this on its own is not the solution. And this is when I'm going to take you back to my slide. Oops, slides. Yes. And let's present again. And obviously, I have some rules. You can follow them or not. It's up to you. So change one thing at a time. It goes without saying, right? You cannot make sense of test results if your changes are not atomic. So whatever you're testing, just change one thing at a time, test again, change another thing, test again, and so on and so forth. Test under different conditions, very important. Have a mixed load, right? You can have something that runs as a term query, or something that does aggregations, something that has range queries, anything, it doesn't matter. But combine all these things. Again, observe rule number one, change one thing at a time, but test under different conditions, okay? Also make sure you, depending on your load, obviously, test whilst you're writing to the index. You might find that the results can be very surprising, okay, whilst you're running your tests. I've mentioned this, do not block the framework. Okay, make sure everything is done asynchronously, otherwise your test results are not going to make sense. And also profile your test code. Initially, when I was running this, I was caught by surprise. There were some results that I just could not believe were that slow. It turns out that what I was doing was just plain old bad code. I had to profile my test code, find out where I was creating more objects than I needed to, where I wasn't asyncing something. But it's really important before you actually unleash this that you make sure that it's as good as it can get. Cross-reference with Kibana. If something doesn't make sense to you, always go take a look at Kibana. There's a wealth of information in there, and most of the times you can put two and two together and come to very, very interesting conclusions. And repeat your tests. A single test is really never good enough. Do 5, 6, do 10 if you can. If you can do 10 tests and you get, very small variances between them, then you really know you're on the right path. But a single test doesn't mean anything. Your next test may be, you may have a test that's really slow and the next test is really fast and then really slow again. There could be a cache that's being evicted. You just don't know what's going to be happening, right? So repeat your tests. If you see that things are all over the place, then start looking someplace else. All right. So let's go back to our Jenkins and let's see whether our load test has finished. Yay. And look at that. That curve actually looks pretty close to what we had in the beginning. Our fastest index is the one with 5 replicas. In fact, let's see if we can get this out of the way. There we go. Okay, thank you. So here are the BRFSS indexes. That one's got 5 primaries. That was got 1, 2, and 3. Okay. And here's your 1. Here's your 2. Here's your 3. And here's your 5. Why did it not do 4? Because it will probably be around here and there's no point. Right, but you can see that we're really close, 49 milliseconds, 71, 70. So we know we have a really good test. Just for fun, let me show you what we can do. So we're gonna actually do let's do 40, why not? So we're going to do 40 users, 2 minutes. And we're going to do this against the good within quotes index. We know that's the one that's working. And I'm just going to fire it off and leave it in the background for it to run. Oh, actually, I can show you the console output. So you have what you have from the Jenkins perspective, and you can have a very quick overview when you see the load test, and you can download the results and you can pour them out your house content. But you can also, you don't have to wait for the test to finish completely. You can actually take a really quick look whilst the test itself is running, because Gatling can and actually does do a pretty good job of reporting to you while it's running the test. So now, if you notice, I said that anything above 30, I'm going to split into 2 nodes. So now you can actually see that instead of just running a node 0, I've got 2 tests. One runs on node 0, and the other one runs on node 1. And this is what Gatling reports to the console. Okay, you can see the OK requests, KO requests, the ones that have failed. These are the ones that are waiting to be injected in your test, the waiting ones. Active is the requests that have not yet finished, and done is like obviously done. But you can see that they're running on separate nodes. So you can imagine if you have a huge fleet of Jenkins nodes, you can really, really hammer your system. And obviously be careful. I'm not going to accept the responsibility for breaking stuff. So this looks good for now, but you can see that the active ones are actually starting to go up. And this is usually a bad indicator. It means that our system is really not coping, because it's not pushing out and processing the connections and the requests as fast as it could. And that's kind of normal. For the Elasticsearch setup that I had requested, I'm kind of going over its limits. It doesn't have a ton of RAM. My query is probably not optimized. The index could probably use a little bit of work itself, but this shows you quite neatly how hard and fast you can go against your system, right? You can test it completely to destruction, find its higher limits, and then see if you can go above them, or just declare at that point that, this is as fast as I can go. I can't optimize this any further. This is my SLA, and that's what I'm expecting. Right, and that brings me very neatly to the end. I hope this was entertaining, and I'm hoping you have questions from me.
Thank you so much, Ioannis. That was a great presentation. And we do have a few questions indeed. So I'll go through them. I don't know if you can also see them in the Q&A. I'll just go through them. Andy asks, what was the name of the behavioral test set again?
It is called depends what you're talking. It's called the Behavioral Risk Factor Surveillance System. BRFSS for short and sweet. If you look at the United States CDC, you'll be able to download the setup. Having said that, there is, and I'm sorry that I don't remember it off the top of my head, there is a public Elasticsearch Elastic repo that actually has the data set in a zip format and Python scripts that actually allow you to ingest it into your Elasticsearch node. So I'll try and find it, and I'll give it to Anna, and maybe Anna, you can get it to anybody who's interested after that. But yeah, that's what I used.
Definitely, I can send out a message to everyone and include it in the YouTube video link. Awesome. Next question is by Dima. What did you consider while defining your load strategy for simulation? Constant users versus ramping user count, duration, etc.
Very good question. It depends on your use case scenario. For the testing, for the test that we've done at Insight, I considered ramping users. It has to fit with your profile, right? You have to see out your traffic, and then you have to apply what you see in your traffic it's the Gatling level. So for ourselves, we have a ramp up as North America wakes up and starts and gets into our system. And then, we have a gentle ramp down throughout the day. Again, it really does depend. I mean, if you want to see how your system will respond to an onslaught of bots that suddenly hit it all at the same time, by all means, send a ton of concurrent users immediately. Don't bother ramping it up. If you have something that may have caches that you needed to warm up a bit in order to actually see the full performance potential of what you have, then by all means, ramp it up. Look at the look at the Gatling website. They have literally a ton of ways you can throw user a system. You can put pauses in between. You can do random user injection. There's a lot.
Awesome, cool. Next question by Andy. How big should your test data set be? We have an index with approximately 125 million documents of research metadata. What would be a good test set?
That's your test set, 125 million documents. Again, you have to think about this. And I know I showed you a toy application of this, but think about this from the perspective of your application, right? You have your application talking to Elasticsearch, running some queries, get those queries, or better yet, have your application's library, right? I think you should be able to actually have them as a module or as a jar or whatever it is that you're using somewhere. Plug this into a Gatling load test and run exactly the same things you would run if somebody was hitting your service. Right? If somebody's looking for 125 million documents, run that. I mean, you probably kill the system, but it is what it is. The point here is to actually express the usage patterns of your users. That's what you're trying to achieve. That's why this is going to be so close to what you're doing, and that's why this is so good.
Awesome. And another question by Dima. Did you ever hit Elasticsearch search queue limits? Is it something you consider while defining the benchmarks?
I have. But at that point, we had actually hit the SLA of what we considered an acceptable amount of requests per second. So it didn't matter, right? Sure you can. I think I've managed to throw, let me see if I can remember off the top of my head. We've managed to throw in 3,500 users a minute. I mean, the sky's the limit, right? As long as you have resources on your node, on the thing that's actually going to run Gatling, and you're not going to choke your network, your memory, or whatever, just throw as many as you can at it. Find what's the worst you can do to your system, right? Where does your system start slowing down? Where does your system falls over? These are very interesting things to discover.
Okay, and we have a question by Lee. What version of Elasticsearch are you testing?
6.8. But it doesn't matter. You can test whatever, right? Think about it, I'm testing 6.8 just because it's something that I'm more familiar with. There's nothing stopping you going to testing 2, God forbid, 3, 4, 5, 7, whatever. Because you are testing Elasticsearch to a point, but you're testing it because you're pulling in your code, your application code that happens to have the dependency on Elasticsearch, right? So think of, again, I think I've said this again, think of the wider picture. You can either go really, really low level, test queries directly, write queries into Gatling, right? You can do this, nobody's stopping you. But you can also test your application as it interfaces with Elasticsearch, and you can discover all sorts of interesting things there. You might find Elasticsearch is never the bottleneck. You might find that your application's somewhere between the query going to Elasticsearch, coming back, being processed. That's where the bottleneck is. That's why this is so interesting and so useful.
Great. Those were all the questions we had. Thank you so much, Johannes, again for the great presentation, for your time.
My pleasure.
Thank you everyone for attending. The video will be up on our community YouTube channel tomorrow. I'll also post it on the events page. So yeah, thank you so much again for joining, and have a lovely evening. See you at the next meetup.
It was a pleasure. Thanks for the great questions, everyone. Bye-bye.
Bye.